Okay, so we got us a problem in front of us. I got a piece of paper, figurative piece of paper here. Let's take a look. So this is problem 1.26 from chapter 1. And so it's chapter 1. Well, just if you put 1.26, of course, there it tells you right away. All right. So a spelunker, huh? Is surveying a cave. So I see north, south, east, and west. I see, and it calls for, this is a problem where we need things to be scaled. Yep, use a scaled drawing. So I'll try this. I wonder, is there another way to rotate this? Oops. Come on. It's going to keep bouncing back between 80 and 90, right? Actually, I probably have somewhere a grid, which, well, we'll do our best here. So all right. Well, that stinks. I want to make little marks on this thing, but it won't let me write sideways. Okay, well, I have another idea. First, let's rotate this again. All right, look at that. Okay. So she follows the passage straight west. Okay, so I don't see any reason not to use the x-axis as straight west, right? So why not? So 170 meters. So can that be, I think 17 centimeters is too much, but we could go half centimeters maybe. 1, 2, 3, 4. Wait, I gotta lose count here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, no way. So 100, so it's 8.5, right? 1, 2, 3, 4, 5, 6, 7, 8.5. So let's see. And so I'm going to start right there. Guess that's too big, but all right. And in a direction 45 degrees east of south. So that means that east of south. So that means tipping this way. All right, 45 degrees. pick that, and then we have to also get that in there. So wait, where is it? That's it. Let's pick a different color. And maybe not so fat. So 210. So let's see. 21. I don't know if our model is going to work here. So, oh yeah, half of that is 10.5, right? What? So it's 5, yeah. One, two, three, 4, 5, 6, 7, 8, 9, 10. And we got to do half of that. Okay. What's next? And then 30 degrees east of north. So that's something like this. All right. Yeah, that's what I think. Now, wait a minute. Yeah, east of south. That's right. So that's east of south is this way. So I got that one right. And now I want to go 30 degrees. So that would mean this should say 60. All right. You know, if I make a mistake, guys, make sure you chime in. 280 now, huh? So that's 14 centimeters. 14 centimeters. Oh, let's try this one. Oh, you got to get the ruler right on there. Let's pick a big one. No, 14.5 centimeters. Yep. So that's 7 centimeters. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay. Now, she finds herself back where she started. Okay. So, in other words, she has a displacement of 0. Okay. Well, that looks like it's going to be a round number, too. So this is 1, 2, 3, almost 4. Let's see now. We know that. Oh, yeah. So it's 2, 4, 6. Yeah, I don't like that. 1, 2, 3, 3.5. Let's say 3.8. And we were saying that a half centimeter is 10 meters or 20 meters? I think it's 20 meters, right? So we said 7 centimeters for 280. 7 centimeters for 280 meters. So we need number of centimeters per meter, or meters per centimeter will be easier. So this is 7 times 10 to the negative 2. So that's going to be meter 280. Enter. 7e minus 2 divide. So, holy shit. 4,000 meters per centimeter? No. Oh, well, I don't need to convert that. I'm being an idiot. We want meters per centimeter, not meters per some strange number of meters. 280, enter, 7 divide. Yeah, that's what I expected, something like that. So it's 40 meters per centimeter. So we measured 3.8 centimeters. So we it's easier to multiply it this way. 4 times 8 is 32. 4 times 3 is 12. Plus 3 is 15. Okay. 2 significant figures. So you see what that means then. That would be 150. Let's see what happens. Ooh, smoking. Okay, so let's see. If this was on an exam, the first thing that you should do is I was doing this without thinking. It's just sort of freestyling. So you want to come up with a scale first, or at least early on. First thing was the axes, the directions, and then it said, let's see. So it said 45 degrees east of south. So if I wanted to be real clever, which is always a good thing, I could draw a little, say this is east of south and 45 degrees. And this one is east of north. East of north. Or you could put it nearby each vectors. And then it's nice to have the colors. And then it's always good to point out that the resultant here goes from, oops, that's odd, from the last head to the first tail. So these are all, these are all head to tail. That's important. Vectors have to add head to tail if you're going to do it graphically. So we might say A, B, C, resultant. So A is 170 meters west. B is to 10 meters, 45 east of south. And then C is 280 meters, 30 degrees east of north. Okay. And then, I've left out one little detail. The resultant goes from, in this case, to the last head to the first tail. And let's be careful here. That's only because R has to end at zero. It has to end at the start point. Because, you know what, I just realized that if I was adding these vectors together, in fact, we're not adding these vectors. Well, we are. Ultimately, R is not the resultant, it turns out. I just realized. So just so we're not being confusing, we're going to not call it R. We're going to just call it D. Because if I was adding A, B, and C together, the resultant would actually point up to here. That's, I forgot about that. So when you do a resultant goes from the, just FYI, a resultant goes from first tail to last head. Since I had convinced myself that D was the resultant, I was forcing the explanation, and it just wasn't true. So yeah, this is not relevant. D has to end at the origin. So then you'd say that this is a scale drawing. So magnitude of D equals length in centimeters times, give me a minute. Yeah, 40 meters per centimeter. So, so to get, we measure the D on the drawing to get the centimeters, and then you convert. Okay, that's part A. Well, that's unfortunate. Well, we'll make it little a, I guess. 126A, like that. Oop. Is anybody having any problem with this, with vectors? I mean, I'll skip up to chapter 2 if you like. If I'll finish this problem. But let's see, what's the list of problems? Components of vectors. What else? Products of vectors. Okay, I'll make a list of that, and we'll see if anybody wants this. I guess we can be more efficient because you guys are more interested in. You may be more interested in other problems than this one. Okay, so now it wants to know the direction. Okay, let's see if we can figure it out. Is there any way to shortcut it? Or do we have to do this with grind it out? All right, I know something that we can do quickly. Let's just, oh, that's not 40. Okay. Oh, wait a minute. Nice. Now, if you didn't have a protractor, what would you do? So we see that this is 38 degrees here. Is there some other way? I'm not sure. Let's see. We know this is 45. So if vector B is 210, then this length here is 210 times that's cosine of 45. So then what's the length there? So, oh, yeah. Let's see. This would be, yeah, we can reason this out, right? Because this has to be 45. This has to be 30. So we want to know it's right on the tip of my tongue. I know what I want. We want to know this projection from here to here. Now we don't know that's 38. If we knew that was 30, no, this one is not a 38. There. Oh, right. So this one has got to be 60. But where is the, okay, so that would be the opposite. So cosine of 60 is 1/2. Okay. So the distance from here to here is the 280. No, it's opposite. So it's sine of 60. Yeah, but I don't like that because the distance from here to here is longer. Right. So this is, yeah, that's the cosine. Yeah. That's the cosine. Cosine of 60, which is also equal to 1/2. Okay. Excuse me. So then this distance here is also equal to 170. Wait a minute. 210, right? 210 sine of 45. And that's going to be negative. These are, we can just add these two together. But now, well, no, we have to, wait a minute. Yeah, we start from 210, then we subtract that. You guys want me to do this out long ways, or do you follow what I'm doing? I have my sound on? No, it might be a little low. Okay, I'm okay. Yeah. You see what I'm doing? I can piece it together. I recommend you always have a protractor with you, right? Because then it's trivial if you had a protractor. That's the whole point of making a scale drawing in the first place, so you don't have to do what I was just doing. Okay.